Okay, so this is number 1 on your review. Okay, we're going to look at, for each relation, determine the domain and range and whether the relation is a function. Okay, and we're going to explain our reasoning. Okay, so for the domain of A, we're looking for the x elements of the points, okay? And that's what we've got here. It's just a series of points. It's not like C, okay? So we're not going to have that x as a part of the real numbers because we just have 1, 2, 3, 4, 5 points there. Right? So we're just going to list the elements with no repeats, okay? So we're going to have -1, 0, and 4, and you'll notice that there's another 0 at the end, okay? And the range is going to be just the y elements, right? So 0, 1, 5, and 6. Now, just in looking at that, okay, if we're taking a good look, we're going to notice that we have 2 x values, okay, that repeat. And then subsequently, because they've repeated, we have different y values, okay, that breaks the definition of the function, right? It says, a definition of a function says for every x value, there can only ever be 1 y value in order for it to be a function. So these are not, or this series of points is not a function, likely because when I look at 0, I have a point at 1 and a point at, 0, 0, 1 and a point at 0, 6. That now fails the vertical line test, so we're going to say that this is not a function for A. Okay, for B you can recognize as, if I wanted to rewrite the equation, we're going to have -x plus 4. That's just a line. Okay, it's a line with a y-intercept of +4 and a slope of -1. And we know that all lines, with the exception of 1 or 2, have the same domain and range. Those 2 exceptions are going to be a horizontal and vertical line. Okay, all other lines are going to have a domain of XER because I don't have any restrictions on what I can substitute in. And subsequently, because that's true, the range is also going to be YER. Okay, if I have so these lines we have said in the past are functions with the exception, the only exception would be a vertical line, so something like x equals 4. Okay, where all values of x are equal to 4, that means it's a vertical line. Okay, question C. Okay, question C looks like an absolute value graph that's been turned on its side, but the best way to determine whether or not it's a function is to just apply, especially when you're provided the graph, just apply your vertical line test. And we'll see that for a whole bunch of x values, we're going to have repeated y values on this particular graph. So we're going to know for question C for sure, not a function. Okay. It's domain and range now. So the domain, we're going to look for the value of x where the graph does not go below or above. So in this particular case, we have arrowheads on either end of the graph, so we know that this is going to go in this direction forever, in the positive x direction forever. But we do know that it's never going to be over here, so that's going to be less than -4. And so the domain is going to be a part of the real numbers such that x has to be greater than or equal to -4. Okay, and its range okay, because that graph is going in this direction forever as well as this, we're thinking now vertically, like our thought process is not left, right, it is up and down, and there are no restrictions in the y direction. Okay, so we're just going to have YER. Right? I don't need that bar, I just need y as a part of the real numbers. Okay, and question D, Remember, a large part of this is recognition of what the function is. And we discussed what this was in grade 10, but also, again, just a refresher, this is the equation of a circle, okay, where x squared plus y squared is going to equal r squared. How big is the circle, and how do I know what the domain range is? Well, you're going to force this to look like that. The only way for that to be true is if r is 4. And so if r is 4, I'm going to get my equation back there, right? So what's that mean? Well, if I'm looking at, if I drew myself a little graph, that would mean that I would have a circle centered about the origin, whose radius, that's pretty good, I think, whose radius is 4, right? So everywhere along here, that's going to be, oops, sorry, that's going to be positive 4, negative 4, and positive 4, and negative 4. Okay, so it's domain and range. For sure, though, right off the bat, though, if we just mentioned this idea of a function versus a relation, that is not a function. It's going to fail the vertical line test. Okay, so what we're going to take a look at, though, is what its domain range is, because it does have a particular area of the graph where it is valid, right? So D, not a function for D. Okay, its domain is the set of x values where the graph is acceptable, right? So it exists, or acceptable, or where it exists, I suppose. So it can take on all values of x, okay, such that they fall between negative 4 and positive 4. What's that look like? Well, you can write it like this. Negative 4 is the lower boundary, x in the middle, higher boundary on the top. And what you're going to say is x is going to be greater than or equal to negative 4, and x is going to be less than or equal to positive 4. That's how you would write the domain. You start in the middle and read outward. And what's great about this particular notation is this never really changes if you write it in that order. Write the lower boundary, the variable in the middle, and then the upper boundary. Okay, and subsequently, we're going to apply the exact same thing to the range. Right? It can take on, and then the range now being the y components that are acceptable for this graph. So we're going to say y is a part of the real numbers such that the graph has to, again, exist between negative 4, y this time, and positive 4. Okay, so again, we're reading y has to be greater than negative 4, but less than positive 4. Okay, so that's number 1. Okay, hopefully you found that useful.